Now, there are several important facts that we have to understand about correlation and regression. The first is that correlation and regression describe only linear relationships. Now, we can still take two sets of data and make a scatter plot of it. However, if that data is curved or a cluster, meaning it's not linear in any way, then correlation and regression are not going to help us. The second important fact about correlation and regression is that prediction outside the range of the available data is risky. For example, if we had a set of data about the heights and ages of children from 3 to 8 years old, and if we made a scatter plot and we made a regression line and we found that children were growing at about 3 inches a year, okay, what we wouldn't want to do is to use that data and to make a prediction about how tall that child would be when they're 30 years old. We all know that when you reach a certain age you stop growing or you slow down. But if we assumed that the pattern of growing 3 inches a year continued your entire life, by the time you're 30 you would be over 30 or 9 feet tall, which would make no sense whatsoever. So you don't want to go far beyond the range of the data if you're going to make any predictions. The third important fact about correlation and regression is that both of them are strongly affected by outliers. To illustrate that, we'll look at an example of a scatter plot of the maximum 24-hour precipitation in inches for all 50 states versus the maximum annual precipitation in inches for those states. What you can see when you're looking at this scatter plot is that Hawaii, way up here, is a major outlier. It's nowhere close to these other dots, nor is it anywhere close to the general pattern. We have here two lines as well. Both lines are the least squares regression lines. The darker one, however, is the regression line that includes the outlier of Hawaii, and the dotted line is the one that does not include Hawaii. Before we talk about the regression lines, we'll talk about the correlations. The correlation, when you include Hawaii, is 0.408. But if you were to take Hawaii out, the correlation drops to R equals 0.195. So the correlation drops dramatically when Hawaii is not included. You can also see that the regression line changes dramatically. Here it is when you include Hawaii. If you take Hawaii out, it drops to this dotted line. Okay, so you can see that Hawaii strongly affects, or the outliers strongly affect, the path of the regression line. And we should understand also, if we go back to correlation for a moment, is that if you drop the correlation from 0.4 down to 0.195, you can see that when Hawaii is taken out, there is nearly no correlation between the maximum 24-hour precipitation and the maximum annual precipitation. It is basically a flat line, which indicates little to no correlation.